Welcome students to this GCSE Geography lesson as part of the coast topic. In this lesson, number 6 in the topic, we will be exploring landforms created by deposition. In the previous lesson, we explored erosional landforms such as stacks and wave-cut platforms. Now we're going to look at their cousins, the depositional landforms. Please write the date, title, learning objective. Write 1 to 10, answer the questions, and then mark your answers. Marks out of 10. Well done. Let's go. Check this out. It's a famous coastal spit on the Gold Coast of northeast Australia. I'm going to show you some questions about it. Let's see if you can work it out. The other one is on the west coast of the USA. See if you can answer these questions by saying them out loud as to predict what I'm going to show you in this lesson. Right. Spits, bars, tombolos, beaches, that's the story of today. Let's go. Key question. First, in order to understand the landforms created by deposition, you need to understand a fundamental process of transportation that happens along the coast, longshore drift. You may have heard of it. Here's what it is. Longshore drift is simply the movement of sediment along a coastline by waves that are approaching the coast at an angle rather than perpendicular, 90 degrees. Here's how it works. Along some coastlines, the prevailing wind, P-R-E-V-A-I-L-I-N-G, the prevailing wind, meaning the most common wind direction, is at an angle towards the coast. We say it's at an oblique angle. As a result of that, this is for example found a lot on the south coast of England, the waves, which are, as you know, produced by the wind, arrive at the beach at an angle themselves. And that sets up a key process, longshore drift. Because you see sediment, like this rock here, are picked up by the wave, and then the swash of the wave pulls the sediment up the beach at an angle. However, the backwash, due to gravity, always pulls sediment straight back down, because water will always take the shortest route back down. Consequently, the sediment arrives here. However, the next wave comes in, and so the process repeats again and again and again. And thus, over time, sediment is transported along the coast. This is longshore drift. So what does this have to do with depositional landforms? Well, let's talk about our first landform, coastal spits and bars. You may wish to draw this diagram. Make it about 5 lines high and about 5 centimeters wide. You're going to put notes to the right of it, and then the next 2 diagrams, hidden right now, put them below each other. So I want you to imagine we have a beach here and the sea, and the prevailing wind approaching the beach at an angle. This sets up longshore drift along the beach. Sediment is being pulled from a west to east direction. As the sediment moves along the coastline, it may reach a bend in the coastline, for example, along a bay or an estuary. When this happens, the sediment doesn't just stop. No, it is transported across the bay or estuary by the longshore drift, by the waves. And when the sediment moves across the water, it slows down and is deposited. And consequently, that sediment builds up along the bay, along the seabed. And over time, it builds up and builds up and builds up until it rises above the surface of the water, forming a spit, an extension of land across the bay. If I show you this in full, the spit ends up looking something like this. It has a curved end called a recurved end. Why? Because when waves come through this gap, friction with the end of the spit here causes the wave to be pulled to the left, wave refraction, and thus dragging some of the sediment with it, creating a recurved end. The wind also serves to pull the spit around. Now here's the magic. Behind the spit, you now have a sheltered area of water where the waves are not operating. There is very low velocity water, and so any sediment in the water is deposited over time. It builds up under the water and eventually reaches the surface to create a layer of mud, flat layer of mud at the surface, which is known as a mudflat. We geographers are imaginative like that. Over time, however, sometimes a mudflat might continue to rise and get higher than the level of the sea, and consequently the waves will no longer pass over the top of it. And because of that, when it rains on the mudflat, and because there are no waves, the salt is washed out. And when that happens, certain halophytic plants, that is, plants that can survive salty conditions, are able to grow. And when that happens, you end up with a salt marsh, which is an ecosystem in which plants and animals like birds can survive. That's why you find shallow areas behind spits, because they're sheltered until deposition happens. If there is enough sediment being transported, and if the bay area here is calm enough and there's no river passing water through here, so it's not an estuary, you can have the sediment continue to be transported all the way to the other headland, like this. And when a spit connects two headlands like this, you end up with a bar. And behind the bar, you have this isolated area of water called a lagoon. Thus, a spit becomes a bar when it connects two headlands. This is our first depositional landform, spits and bars. Let me show you some photos. This is a famous spit called Hurst Spit, and that down here is Hurst Castle. You can see how on the front of it there's deep water and, generally speaking, waves. Behind, the water has become shallow and you can see salt marshes starting to form. You can see the bottom of the water here, the seabed here, as deposition has happened. It's calm and sheltered. You can also see how the spit curves at the end, the recurved end. This is a spit and the salt marsh. A bar, by contrast, is this, where the spit connects up two headlands like this, and the lagoon sits behind. Finally, a special type of bar is a tombolo. A tombolo doesn't connect two headlands, but rather it connects the mainland and an island. And a tombolo forms when waves pass around an island like this. Wave refraction causes them to bend in towards each other. They meet each other in the middle. The velocity decreases dramatically as they meet each other and cancel each other's velocity out, and any sediment they are carrying is deposited in between, and it builds up to form this tombolo. Thus, we have spits, salt marshes, bars, and tombolos, but they are not the only depositional landforms. We also have beaches and sand dunes. Now, beaches form in a fairly simple manner. Generally speaking, constructive waves deposit sediment along a coastline because they have a strong swash but a weak backwash. Beaches tend to start as pebble beaches, but over time, due to attrition, will erode down into sandy beaches, as seen here. Beaches tend to form in sheltered areas of the coastline, but not only. They are built up by longshore drift, but they can also be thinned out and removed by longshore drift. Storms can remove them in a matter of only one night in some exceptional cases. So how do beaches turn into sand dunes here? Sand dunes are these walls of sand that form almost waves on the land by the coast. What happens? Well, imagine this as a beach. The prevailing wind goes from the sea onshore like this. The prevailing wind brings sand with it in the air. And that sand is trapped by loose obstacles that are found on the beach, such as grasses or logs or driftwood that has floated in the sea and been deposited on the beach. When this happens, some of the sand builds up around these objects and forms the first small sand dune over time, called an embryo dune. I'm going to show you these explanations with captions to help you. This embryo dune, seen here, is slightly higher than the beach. This dashed line shows the water table, that is the height of saturated ground. Above it, there's no water permanently in the ground. On the top of this embryo dune, you can have certain types of plant, such as marram grass, M-A-R-R-A-M, that are very resistant to salt. They are halophytes that can start to grow. And these grasses, which with long roots trap and stabilize the sand and thus allow the dunes to grow larger. Due to the wind blowing on shore, these mobile sand dunes are pushed over time inland. Thus, eventually, these pioneer plants on their embryo dunes move inwards like this. And so over time, you have the embryo dune moving inwards and forming this here, a yellow dune. The yellow dune is larger, it's higher up, the water table is further down, thus it's less salty at the top. Because there's more vegetation and more vegetation dying and decomposing, there's more soil on the surface, and so larger, more complex plants like heathers can grow. And that stabilizes the sand even further, causing the sand dune to get even larger. The water table is now much lower relative to the height of the sand dune. And this process continues until you get to a mature dune furthest inland, which is the largest, the highest from the water table, and the furthest inland. And here, the land is sufficiently lacking in salt, and it's sufficiently high in nutrients from decomposed vegetation that trees can grow. With their large roots, they stabilize the sand further. This process of small sand dunes growing over time with ever-increasing vegetation is called the vegetation succession. And this whole system seen here is called a samosphere, P-S-A-M-M-O-S-E-R-E. The samosphere is this whole diagram showing the changing size of vegetation and complexity from the embryo dune through to the mature dune. And that process, step by step, of vegetation getting larger is a vegetation succession, which altogether makes up the samosphere. Thus, the dunes have become less salty inland, leading to larger vegetation and more sand in larger dunes, leading to, over time, the rows of sand dunes that we see. This is the story of the formation of the complex sand dunes such as those found in North Wales. These are the depositional landforms found along the coast. Time to practice. I'm going to show you some questions, answer them in full using the key terms you found today, and then mark your answers. Here are the questions. Pause the video, answer them. Alright, here are the answers. First one, second one, third one. Mark your answers, please. Thank you so much for joining me. Well done.